Hello, my name is David. I work at Babylon Health in London, despite I'm working remotely. And today we will speak about forms and in particular FormsKit as a way to help working with this kind of thing. And you may be wondering, forms, what's really a form? And a form is essentially something like this. A login screen, a sign-up screen, can be a setting screen. Essentially something with this kind of structure where you basically can ask the user to type some kind of information like name, email, password, or even select something from a screen like we see for sign-up where you can select a country. So this kind of components are quite frequent in any app. I mean, almost every app has at least sign up and sign in. So it's quite common to have something like this. But before we start, I will give some context. And essentially, managing state can be really a hard task because there are multiple concepts involved. There is mutation, observation, threat safety. I think everyone agrees that it's not really easy to manage state, especially when you have too many states, like first name, last name, email, password, and you need, for example, check if everyone is valid or not. So it's quite hard. To build a form, we are really interested in mutability and observation today. So threat safety is really fundamental as well, but out of scope for today. The idea is basically providing a simpler image about the state of managing a form. So to help us, I think this slide is not showing completely. So to help us with mutability and observation, we can define a type called property where we can basically store any kind of value. Okay, it can be a string, can be can be a string, can be an object, custom, whatever we really want. And we have the initializer where we pass the value, and we can access the value of the property with the value property, and we can observe any kind of change in this property. So if I define the property with the value David, and then I change to Rodrigues, I can see this change. It's really interesting and powerful to build code. And we also have this map function that basically transforms our value into a new value. Let's say, for example, that we have a string property, and we want to basically convert each string value to the integer value. For example, we can do this passing basically a transform closure. There's a return property here that's not being displayed, but essentially we go from value that returns t to a new property that contains t. And we can observe each change in this resulting property. Please note that it's really a simple implementation, so it's not something that you probably want to use in production because there's threat safety that we are not covering today. But it's a base for something like I said, let's say, for example, we define a property. We can observe the value of the property at this point. And then when we change the value, we basically see the resulting of that change. And basically, we can observe all the values during the life cycle of the property. And we can also use map to basically derive new states. Like I refer, let's say we have a property where we store a double. We can basically create a new property B with a map where essentially we return a string that basically provides a representation of that value. And as we can see, b.value has this value. When we change a and not b, we can see that the value is changed and is not displaying here, but we are checking the value of b, and b has essentially 10.0 as string, because we are deriving b through a. So every single time that a changes, b also changes, okay? So now we go back to forms, and let's back to sign up screen. In sign up screen, we can see that we have multiple components here. And to build something like this, we can probably create something like a data source and return the number of rows. And for each row, we return the relevant component, like Facebook button, or text, first name, last name, and so on. So the thing about this is adding or removing elements from our form requires two things. First, we need to update the total number of elements, because we need to provide exactly the number of elements of the form to the data source. And we also need to shift all the indices affected. So for example, if we remove the first element, we need to shift all the indices -1. And moving elements also requires a shift of all the indices affected. So unless we place the item at the bottom of the list, we need basically to shift all the following elements. So you may be thinking, okay, but that's manageable. I think I can manage that. And the problem is, when you have something like this, this is our app, where basically the consultant type can change different components in the form, and when you select the date and time, there are multiple states involved. So there are quite a few things to manage. So we can see that our data source needs to change to basically accommodate the consultant type, because depending on the type, we need to display some components or others. Also, for example, for GP, we need to check if that date and time is available or not. So there are multiple things involved. It's not that easy to manage these kind of things. And the thing is, and how can we get these animations that look really nice instead of reloading all the things? And that's the moment where we basically starting to be scared about all this mutation and the crashes that happen when you have basically inconsistent data source. So it's kind of hard to do something like this. And index paths essentially are a weak system, which are really hard to manage and maintain, especially when we need to deal with dynamic changes. They are really hard to reasoning about. So what's then? What's the alternative to basically improve this system? So to go there, let's forget everything. Let's ignore index paths. Let's forget completely anything. And let's start from scratch. And we can ask ourselves this question: what's really a form? And a form is essentially a collection of components following a sequential order. Okay, this actually makes sense. And we can see on sign up screen that we actually have different components, like Facebook button, text input, selection, buttons, and so on. There are multiple components there. So if we focus this sentence, we can basically identify three components: form, collection of components, and sequential order. And if we check in particular this collection of components with a sequential order, it may, there's something similar that we work probably daily basis, which is array. Array is essentially an ordered random access collection. So we can represent a form with a collection of components. And the collection of components can be, like we saw, text input, password selection, buttons, and whatever you want, basically. If you need to provide some custom interface for your project, it can be a component, right? So we can define an enumeration called component and essentially declare all the cases for the components that we support, like text, where we receive the string that's going to be displayed, text input, where we receive the placeholder and other stuff, password, and so on. So we can represent this, and then we can define our screen like this. We define an array of components, okay? And we declare the Facebook button, which is essentially the first element. Then we declare the text for or, text input for first name, text input for last name, and so on. And look into this. By using an array, we already have the row number for each component. So we don't care really which index is email, because the array provides that for us. We are abstracted from that. So by using an order collection, we can basically derive the respective state, which in this case is our index path, with a clear and declarative way, because in this case, we can clearly see the interface that will be displayed. And for example, if we look into the data source, it's not that easy to understand exactly what's going to be displayed, right? So let's see if we can basically fix some of the problems that we saw with index paths. And adding, removing, or moving elements is really easy, because we just need to place the new element or remove the element or move. The indices will be naturally updated because we are using an array. So this is cool. But the question is, how do we go from a collection of components to really a form? Because at this point, we only have a representation of the form. So for this, we can essentially declare some protocols. Our form that will be based on a property, so the initial property that we saw, with the components, okay? Then we have a protocol to represent a component, which is called form component. And this protocol declares two methods. And then we can see that there's a method in specific which is called render. And why this is important? Because we can represent a component without thinking in the interface, just the data that the component will have, like title, placeholder, and so on. But when we implement the data source, we need to provide a cell or a view to the table view. So we need a method to go from a component to the interface that represents that component. And we can provide that with this function, render. We have this protocol for methods that can be useful to the component. And then we can change essentially our component to conform with this protocol, okay? Just a small disclaimer, the following examples are based on MVVM, okay? And MVVM essentially has this separation between the view and the model, okay? Essentially, all the logic with binding and triggering actions is moved from the view, mostly the view controller, to the view model. And the view model is the entity that basically interacts with the model, okay? And yeah, I'm not covering the the details about this. I'm just telling that it basically can be used by any pattern. If you want to use MVC, like there's this trend about reviving MVC, you can use it with MVC. If you want to use with MVP, you can use it as well. So it's not really tied to any pattern. So in this case, we have the sign up view model, and we comply with the protocol form. So we need to declare our property that contains the components, okay? And we need to define the initializer, and basically we define the property with the values that we saw previously, okay? So we have this view model that's essentially a representation of the form. Now we have this implementation, form table view data source, and form view controller, okay? Which are essentially the core and the base to get this form. And looking first to the form view controller, we basically receive a generic form, so it can be anything as long as it complies with form protocol, okay? That's the only thing that's relevant for this controller. And we have a table view, we have the data source, and we create the data source using the components of the form, okay, which is a property. So the table view data source essentially will be this initializer where we receive the components, and we start observing changes in this property, okay? And every single time that there's a change, we cache the list of components, and we trigger the reload data. So at that point, the table view will call our data source to return the number of rows, and the number of rows will be just the count of current components. And we need to provide the cell for row as well, and we essentially will call the method render to go from a component to a view, okay? So our actual view controller will be something like just this. We receive the view model, and we call the super initializer to provide the form to the form view controller. So this is really nice, but what if we need to have a dynamic list of components, like we saw in the previous example? So let's define a simple one, which will be a sign-in with two types of authentication. Let's say, for example, we are interested in authentication with email and password, or email and membership ID. So essentially, we want these two screens, and we want to go from one to the other every single time that the switch is enabled or disabled, okay? So we can start by defining the type, like we can have the standard sign-in or the membership sign-in. And we start with defining our view model that complies with form. We declare the property to store the components. But the question is, how can we define the components? Because they need to be dynamic. So essentially, we want something like this. We want to have a sign-in type, and then switch to, if it's standard, I want these components. If it's membership, I want this, okay? So first, we essentially need a trigger to do this change, okay? Because when the toggle is selected, we go from one to the other and the other way around. So notice this toggle that we represent, and one of the data that this toggle can receive is this property is on, okay? And this property gives us two things. First, we can define the initial value of the toggle, if it should be disabled or enabled, actually selected or deselected, just to be clear. And then we can essentially observe any kind of changes. So the component will render the view, and any change in the view will change this property. And if that's the case, we can observe if the toggle is selected or deselected by the user, okay? So essentially, we can continue the view model and define this property is membership selected, initially with the value false. And then we can basically define our sign-in type by deriving the state from is membership selected, okay? Because essentially sign-in type is something like if is membership selected is true, it means we basically are in the membership type. If not, it means we are in the standard type, okay? So, and this is really important. We are defining a new state in our system, but this state is basically not managed by ourselves, because we are driving this state from another state that we manage, actually. So with this, we have these two types, and we can essentially define something like this. If we have the sign-in type, we can, and because it's a property, we can map each value to a new value. And in this case is an array of components, okay? So the switch that we saw previously is essentially here. And we know that every single time this property changes, we are basically getting the new list of components, because we provide the toggle with this property. This property is the trigger to the system. Every single time it changes, it goes to sign-in type, and it's actually, we can see here, and sign-in type goes to a new array of components. So, and everything is derived by a single state. We don't manage sign-in type, and we don't manage components. We only manage the initial property, okay? Everything else will be just side effects of changes in this core state. So we can see that in this switch, we basically are repeating the same components in both cases, okay? Let's imagine, for example, we don't have just 2, and we have 4, 5, and so on. Is essentially repeating the same logic, which is not ideal, right? Because if tomorrow someone needs to add a new case and change something, they may forget to change some case, and there's an inconsistency. So there's no better way to compose all of these in a more declarative way. And the keyword for this is really compose. So that's why there's this form builder that essentially can compose an array of components. So we define the list of components. We have the empty as an ND initializer, and we receive the components. So we have one container. We want to start to composing things in this builder, okay? And we can use methods, but we actually can use operators to make these more expressive. So we can define these two operators that essentially does this composition of a new component into a builder, or two builders into a resulting builder, okay? This might be confusing for now, but will be easier to read in a few slides. So we have the implementation, and then we can build something like this. So let's forget the initial two functions. Let's start by seeing the definition of components. And here is complete. So we start with an empty builder, right? Because initially we don't have anything. And then we start to compose components into the builder. So we have a text input into the builder, and then we compose a list of components from this function, okay, actually a builder, sorry. The function will receive the type of sign-in and basically will return a builder, which can be empty or can be a builder with the components relevant for this type. And we use this composition. So we essentially combine two builders into just one. We use the components of the first builder, and essentially we append the components of the second and create the third one, which is the result of the combination of the two, and so on. So see that we are not repeating anymore the text input for email, neither the title for the toggle, and so on. So it's quite interesting. And composing a builder with another builder is really powerful because, as we can see here, let's imagine, for example, we have 2 or 3 screens exactly with the same components. So we can abstract that into a generic builder, okay? And this thing can be combined with any kind of screen to include these components there. So we don't need to repeat the same components in each screen, okay? It's quite interesting. But sometimes the functions can be useful, but sometimes we can even go a little further with a new operator. So we can basically define an optional composition operator, and using this validator that I'm not going to speak in details, it's just a reference. And essentially, we can rewrite our code to essentially do this. We always include text input in our builder. We want to compose always. But the password, for example, we only compose into the builder if and only if sign-in type is standard, okay? It's like an if in an imperative world. So we check sign-in type is standard, so you should include this. Otherwise, it doesn't include nothing. Then the toggle, and the same for the text input for the membership ID. And essentially, we have this declarative way of seeing our form. Here we can see which states can affect the form and in which components we are changing the form considering the state. So considering that we have now a dynamic collection of components, it means we have a dynamic rendering. And look the word rendering, because we essentially are doing a virtual rendering of the form every single time the state changes. So we can define a renderer to render the collection of components for each state. So we can shift the code and have this in a separate entity called renderer, okay? And it essentially does all of this. So our view model will be much simpler because it's always cut here. So we can see that essentially it defines it has the renderer, and it basically maps the state to go to the renderer to get the representation for this state, okay? And the thing is, can we have the animations now? The answer is yes. But if you guys remember, we have this reload data. So obviously, it doesn't work because when the components change, the table is reloading all the things. So it really means, well, not yet, but we are getting there. So every time that our state changes, we need to generate a new collection of components, okay? And basically, it's the representation for a particular state, okay? So there's this concept of pure functions. If you think like, my view can have this state, and for this state, I have this list of components. But my view can also have this state, and I have this list of components. So everything is pure, essentially. You are declaring your view based on a state. So here we can see a quick example. For standard, our view model will have this list of components. For membership, we'll have this. And we can see that there's a small difference between them, right? Is essentially the password and the membership ID. So when we go from standard to membership, we remove the password and insert the text input for membership ID. And when we go from membership, we go to standard, we remove the text input for membership ID and insert password. So going back to form component, do you remember this specific method? This method matches is essentially the trigger to match two components. So let's say, for example, I have this password component, and I have the representation for standard. Now I change to membership. This password component will be essentially different from anything else because it doesn't exist in the membership ID. So for every component, we can match it with other components to understand if essentially is equivalent or the same or not, okay? So we can do something like this. We can define 3 components, 2 password components, and 1 text input. And component A matches with itself, obviously, but A also matches with B, even being 2 different components because they are the same conceptual component. But when we match A with C, which is a text input, it fails, right? Because they are not equivalent, obviously. So if we apply a diffing algorithm, we can essentially identify any change between a collection of components, okay? So there's this project called Dwift that has this function where we pass 2 arrays, and it essentially gives us an array of steps which will be essentially an insert with index and value and a delete, okay? But notice one thing. Yeah, okay. Value needs to be equatable. And our form component, it doesn't require equatable. And there's a reason for that. Essentially, we want polymorphism, right? Because we want to handle any kind of component. So I can have my components, you guys can have your components, and we want to work all of them. We don't want to work just with mine, right? They are good, but okay. So essentially, we can fix this by wrapping the component itself into a node. And the node, it's the entity that's equatable. Because it essentially receives the component and uses the matches method to match the components. So we change our builder to work with nodes. So when we call build, we get the array of nodes, and our form becomes to a protocol where we have a property with the nodes of the form. So after this, essentially, we have this data source that doesn't work for our case. What we want to do, essentially, is this. We have this observation that changes every single time that nodes are updated. And we start a begin updates for the table view. And we apply the diffing between the previous nodes and the current nodes. And this will give us essentially each insert that happened with this transition and each delete in each transition. And with this, we can insert rows and delete rows. And don't forget the end updates at the end. And this is the thing that will give us those animations without any kind of handling in specific to get them, right? Because we only declare the components. We implement the matches method, but we don't care like applying a diff algorithm or nothing like that. The only thing we care, and to recap, we will see this. I will go into this one. So essentially, there's like a flow to get this kind of forms. We have the form, and notice that this can be used with MVC. So if you want, You can have your form inside the view controller. It's up to you. And the core of the form is essentially the form state, okay? That's basically the trigger for any kind of change that your user interface needs to cope with. So in this case, on our example, is just the sign-in type, but can be any kind of thing. You can combine multiple states into a resulting state, and being the form state, you know that when your state changes, you go to the renderer. The renderer will get you a tree of components, which is the collection of components. And because the data source is observing any change in the form, we know that there was a change. So we need to calculate the diff and get the changes. And then we can apply those changes into the data source. And we get those animations that look really cool. And we don't need to be concerned about any kind of logic about index paths and which was the previous state of the form and so on. It basically makes a lot of things simpler. As you probably have identified, this concept is really highly inspired in React. The same concept is used by React to have the virtual DOM, which in our case is the collection of components, and then having two versions of the virtual DOM, they can basically know exactly what changed and apply those changes in the web page without reloading everything. So I'm basically at the end, and the conclusion essentially, there's a high goal of this talk besides the forms. Each essentially is managing state is really hard for any app. When we have just a single state, you can say that's quite easy. I can manage that without any pain. But when we have like 5 states, 8 states, or even 15 states, is quite hard to reason about the system. Especially when you manage the state in multiple places. So it's really hard to make a mistake. And we should try to minimize that. We should have just one place, a core place where we manage our state and then start deriving state from the states that really are mutable. And essentially, one concept that I want to give is state derivation is really a good mechanism to reduce mutability, because as we saw, we are not managing the sign-in type. Everything is basically automatic, and we know that we change every single time that we need to change. FormsKit's ultimate goal is kind of helping, creating, and managing any kind of form, okay? So the idea is really being open for extension, is essentially a framework that you can basically use, and then you can use the components the framework provides, or even write your own if you want or need to. And to achieve that, our objective is making this project open source in January of the next year. There's significant work in the framework itself still, and at the moment we are using functional reactive programming in the concept, which we didn't saw. So it works even without this kind of frameworks. But we want to provide them as well. So we are working to provide different implementations, or something like different bindings. If you want to use it with reactive Swift or RX Swift, you can. If you don't want, we are working to provide a really simple implementation that you can use in your project even without these frameworks. And that's it. If someone has questions, I hope so. I'm hoping to answer them.
Thank you. It was very interesting, very nice, swift work you have there. A lot of things you've done. And I have a question. We worked on creating the registration form, and we were asked to pull out some fields in some situations, like you do. Uh, but but we had a problem using the UI table view because when you uh, select one field, the input field, and it becomes the first responder, and then you scroll up, and it disappears, and becomes dequeued, and it becomes it resigns the first responder. What do you do with that?
Okay, so I didn't mention that, but that's also another feature of FormsKit. So essentially, it can control for you which components can be first responders. So essentially, when you press in the keyboard, for example, next, it goes to the next component that's real responder. So there's logic to support that. For that case in specific, if I recall correctly, I think we essentially keep track of the text fields selected. So if you scroll and go back to that component will be responder, will continue to be a responder because we keep track of that manually, okay? So essentially we have logic internally to exactly know which components are first responder. We didn't saw that here, so there's more APIs behind what we saw here. That's one of them because we need to essentially, for example, the sign up is quite useless to have all these fields and then you need to select each one of them. So you want to press next or even using a toolbar and go from first name to last name and so on.
Does the keyboard goes down, or it's always on the screen?
It's only so initially when you select the first one, and you can basically control if when the form is loaded, if you want to trigger the keyboard automatically or not. So you can control if the user needs to explicitly select the text input, for example, or if I will give you just one example. We have a screen for forgot password, and it's the only text input, and it's quite useless to force the user to select the text input for forgot password. So when the user opens the screen, the keyboard opens automatically. But for example, when you have sign up where there are multiple fields, it's up to you if you want to launch the keyboard automatically selecting the first responder or not.
Well, it's not quite that. And does the contents of the input that you've already inserted and you've typed some information, and when the UI table cell becomes dequeued, and does it get set back when you scroll back to it?
Yep. Yes, we saw one example, like is membership selected? We define this property with the initial value, and this is the property that essentially will define the initial value of the cell. Let's say now you scroll and the cell is basically reused and so on. When you go back, it continues to use the same property. So if you change the property to, let's say, selected, when the cell is rendered, it uses this property to place the correct value. So
and the text too, you mean, if the text field and the text
essentially the same. Like the components itself, they have a few properties, like for example placeholder, which in this case is not dynamic, but for example text is dynamic because it will be empty at first, but then the user can start typing things in text input. And all of this is stored in this property. And this property, unless the view model discards the property, it keeps track of the current value. So when you dequeue the cell for this component again, you are going to place the text stored in this property. So if the user typed David in the previous usage, in this cell for row, we are putting the text David in there, okay? Because the view model essentially is the source of truth. The view model defines exactly what's placed in the interface, like if the toggle is selected or not, and the text in each text input, and so on. You can control all of that.